Lessons 3 through 6, Part B. So we did, oops, I'm going to move up there. We've done the notes for the first part in the other video. Now we're doing these notes for the second part in this video. And I'm going to erase these weird lines I made. Okay, so the first thing, we're now looking at a new function called f of x. And you have to determine, is this a linear or a piecewise function? So, what do you think it is? If you said piecewise, you're correct. This comes in 3 different pieces in this case, right? These would all have, each of these 3 parts would have its own function rule. All right, so we haven't been told the rules, but we have this nice graph, so we can figure out what the outputs are when we know the inputs. So when the input, f of -4, so when the input is -4, so that's our x value, right? So on the x-axis here, we're going to go to -4, which is right here, and we're going to see what is the output. Well, we're going to trace it up to, we're going to find the function, and we could write it as an ordered pair, right? That is -4, 2. That is the output. So when the input is -4, the output is 2. So we would write f of -4 equals 2. And we could, of course, write that as an ordered pair, which would match the ordered pair of that point on the function. Okay, now let's try f of -2. So our input is -2. And we have to go up to the function at -2. Here we are on the function at -2. What is the output? Well, the output is 4. You could write that as an ordered pair, -2, 4, and that would be, of course, the ordered pair of that point on the function. I'm going to let you do these 2 on your own. And then you're going to answer some questions here. Select all the true statements. So let's maybe do one more. Let's do f of 5. So f of 5. So when the input is 5, when x is 5, go up to the function. And it looks like the output is 2. So the coordinates of that point would be 5, 2. So when the input is 5, the output is 2. All right, so let's try this first. Let's try this statement here. Is f of -2 equal to f of 5? Well, we just figured those out. F of -2 is 4. It's this point. F of 5 is 2. It's this point. Those are not equal. So that's not true. What about this statement? F of -4 and f of 5. So f of -4 is 2, and f of 5 is also 2. That is true. So we'll put a little check mark there. You evaluate the rest of these. And this is the greater than or equal to signs, so we know what those means. Is f of -5 greater than f of 0? Well, we have to find out what f of 0 is to determine that. Okay, here we're going to graph some coordinates. So we're told that when the input is -3, the output, g of -3, is 1. So we could write that as an ordered pair. We'll put the input first as an x value and then the output. And then we'll graph that point. So we have -3 and up 1. And that is point A. So we'll go ahead and do that for all these points. Input is 0, output is 3, over 0, up 3, that is point B. So you're going to graph point C and D on your own. Okay, and then the last piece is describing functions. We have these different terms to describe a function. So let's fill out this chart. We have 2 different functions here that we're going to describe. The minimum for a function is the coordinates of the lowest point of the graph. So for p of x, the lowest point is right here. Those coordinates are -1, comma, -3. For f of x, the minimum, this is the lowest point here. Those coordinates are -4, comma, -4. The maximum is the highest point. So for this graph, it's this point here. For this graph, it's this point. So you figure out the coordinates for that. Do one together. This is over 3 and up 1. Okay, so positive, when the function has positive outputs, so that's going to be kind of a range. We're going to use an inequality for that. So this function has positive outputs for this part of it right here. Those are all positive outputs. Remember, the output is on the vertical axis, so the graph is above the axis, x-axis. So we're going to write that as all of the, whenever you put in an input greater than 2, you'll get a positive output. Well, in between 2 and 3. This particular function doesn't keep going. This one has lots of positive. Those are all positive, right? Those are all above the x-axis. So here it's everything greater than -2. Negative is when the function is below the x-axis. The function has negative outputs, so the y values are negative. So for this one, it's all of that there. So it's everything that is less than 2. Right, you figure it out for this one. Increasing. This is when the function's outputs increase as the inputs increase. It's when the graph is upward sloping, left to right. So for this first function, p of x, it's upward sloping in this section right here. That has a positive slope. That line is a positive slope. So it is when x is bigger, when the input is bigger than -1. So this whole portion here. For this f of x, there's 2 parts which are upward sloping, this part and this part. And they're one after another. So it's everything where x is greater than -3. Decreasing would be the parts where it's going down, negative slope. So for this one, it would be x is decreasing less than, or sorry, greater than -4. Or wait, hold on, how should I write that? Actually, let's write that as x is less than -1. And here it's x is sloping, so that is 2. X is greater than 2. Okay, that is it.